All right, Workplace 20 fans, here we go. Let's take a look at section 1.2. That's grade, angle of elevation, and distance. So first of all, let's get some definitions done here. Maybe you haven't heard of it before, but angle of elevation. All right. So basically, what we're looking here is a lot of times we use this another Greek symbol here, and this is called theta. It's a Greek letter for t, and lots of times, so it's just a circle, basically with a line through it, and lots of times it's used as the symbol of choice when you're trying to find a missing angle in a triangle or any other shape that has angles in it. So that's called theta. And what angle of elevation is, it's basically you're looking up from the base up to the top. So this is your angle of elevation. Think about elevation is that you're going up. So the angle of elevation is the angle that you are looking up. Oops, don't forget a G. Looking up from the base. Okay, and this is the base here, which hopefully you'll also kind of make a connection there that your base in this case is also your horizontal, which is your run. All right, so we will do a little bit of trig. We'll also do a unit in trig later on down the road in Workplace 20, and we'll look at sine and cosine, but we're going to look at our friend tangent ratio because we're dealing with right angle triangles here. And what the tangent ratio is you're going to see if this is the angle, all right, this is your opposite and this is your adjacent. Because if this is your angle, this side is opposite. And because it's just like a road, right? Say, there's your hypotenuse there, and this side is your adjacent. Think of it as kind of like, this was the ring road, and you came onto it when you merge onto the ring road. For example, the angle that you would merge at, right, this would be your adjacent angle because you're coming down the adjacent road, right? So that's going to be your opposite over your adjacent. Okay, and that's what tan is. Now, hopefully you can make your connection here too. This is going to be your rise, and this is going to be your run. Then you can also make the thing that tan is also going to be your rise over your run. Now remember, you're going to get a ratio on that, like a decimal, and we'll show you later on how you can convert that decimal into an angle. All right, so hopefully that makes sense, and again, let me know what your questions are and we'll definitely help you out with that. So let's put that in practice, what I just said. Okay, so you're going to find the angle of elevation for the following triangles. So again, you can see there's a little theta. Again, you can use x, but this is the angle in question. That's your angle of elevation. You can see you're looking up there. And here, this would be my opposite. Okay, so in this case, it's 6.8 centimeters. And this would be your adjacent. So that's opposite. This is adjacent. And that's 4.2 centimeters. Notice our centimeters and centimeters, that's going to divide. We can bring in our handy dandy calculator and we can go 6.8 and we can divide that by 4.2, and that gives us a ratio, all right, of about 1.6. Is that what we have there? Yeah, but we'll put to 2 decimal spots and we'll go 1.62. Okay, so I just rounded off. Okay, so that would be our slope, but that's also the ratio between rise and run. Now, to figure out what this angle is, right, we have to do something special to this. And if I bring up my calculator again, you can see here that this says tan, all right? But if on this one, I would have to see, let's double check. I know on our calculators there's a second function that we would need, but I want to see, no, that's not what we want. Oh, I bet you if I brought down more, I could probably see this a little bit better. So again, knowing your calculator is really important. So if I go 1.62, what I want to be able to do here is take not tan, because it's already in tan mode, like I already have the ratio here, but to convert it over I need to be able to, so let's try, no, Oh, yeah, look at that. I figured it out on this. So this was like my second function. You can see here, it's a good lesson in itself. This is tan to the -1. So what this will do when I touch on here, it'll take this 1.62 and it will convert it into that angle that we're looking for. So when I go there, oh, beauty. That is 58 point, what did it say again? 58.3. And in this case, another really good point to know is that you have to make sure you're using degree. Okay, it can't be rad or grad or any of those other ones. It's got to be degree because that's what angles are measured in this case. So the key thing to add to this too would be a little degree sign. So there we go. There's the angle of elevation for this angle there. So I'll let you try the next one and see if you can work your way through that based on the example given. All right, so let's take a look. There's a couple more examples here. Let's go through example number 2. All right, so the key thing here, we're reading, we're trying to decipher what's going on. Brad needs to unload a quad from the box of his pickup truck. He places an aluminum ramp at the truck bed at a slope of, okay, there it goes. There's where we talked about before in a previous section. There's a ratio, okay? It's 7:40 or 7/40. Okay, so remember, if it helps you, drawing pictures is amazing. So I'm just going to draw here his little ramp. He's going to get his quad up. He's telling me here that, remember, the first number here would be your rise, and the next number here on the bottom would be your run. So also here, this is a right angle triangle, and we want to know what the angle of elevation is. So we're looking for here. Right, so we would have opposite, right, which would be 7 over adjacent, which in this case would be 40. And we bring up our calculator, and we will put that back, go to here, and we will go 7 divided by 40 equals, so this is 0.1, what do we have there? Double check. 0.175. All right, let's minimize that. 75. Now, as the previous question here, this gives us the ratio of what this angle is. So we have to bring back our calculator, hit that, in this case, the arrow on your calculators that we use in class. There's a second function. Make sure you're in degree, right? You want this tan to the -1. So boom, there you go. And that means that 9, the angle of elevation would be 9.92 degrees. Okay, so that would be our angle of elevation. So that's this guy right here. So we just figured that out. Okay, that's really important because if it's too steep or not steep enough, if it's, you might have to build a longer ramp, or you can't get it up if it's too steep. So it's really important. So this is a really interesting question, and we really haven't talked about this. How long is the ramp? Well, we're going to have to draw back into a couple of ideas. And remember our friend Pythagoras, our Greek friend Pythagoras, he taught us an important theorem that if we have a right angle, this is always going to be the hypotenuse. So the hypotenuse would be how long the ramp is. So we would need to use this formula. Now, I know we're used to saying a squared plus b squared equals c squared, and that's okay, but really it's the leg squared plus the leg squared equals the hypotenuse squared. And the reason I say that is I don't want people to get tricked. If this was c and this was b and this was a, well, you'd still square this and square this, and then a would still be on the longest side. So you still got to take the two legs, all right? And hopefully we understand that. So we have one leg is 7, and we're going to square that. And we're going to take the other leg, which is 40, and we're going to square that. And then that's going to give us what our hypotenuse squared is. Remember, we just want to find what the hypotenuse is. So 7 squared, I think that's 49. That's pretty good. 40 squared, I'm going with 160, but I just want to make sure. So let's go 40 times 40 equals, oh, look at that. See, I was wrong. So it's good that we did that. 1,600, which makes sense. Add those two together. you get 1,649 equals hypotenuse squared. Okay, and now you want to remember, you just want to find the hypotenuse, so you got to get rid of the squared. So the opposite of squaring is to take the square root. So that's our little friend, the square root sign that looks like a hat, right? This square root and this squared, it's basically what they're doing there is when you multiply those, you're going to get 1, because like a half times 2, which is 1. So you're just going to find out what your hypotenuse is. And then if we go back to our calculator, I'm going to add 49 on that. And our friend, the square root on this is, let's see, oh, there it is. Let me go back, see that? Little check mark, and that's 40.6. So go there. This is going to be 40.6. And we have to make sure we know our, on this, that's interesting because it never really does tell us the units there. So we're just going to go 40.6 units because it never tells us if it's meters or feet or anything like that. So whatever this is, it's in units, and that's how long it is. So that's a good thing to know too. Okay, so that would be how long it is. It'd be 40.6 units. We don't have enough information to say whether it's meters or feet or what have you. Woof. All right, we're doing some good math here. I'm really excited about this. Let's take a look at the slope. I just wanted to give people a little bit here too. The slope of a driveway must have a minimum angle of depression of 1 degree. Okay, so just so you know what angle of depression is, if you're looking here, the angle of depression would be this angle here, which is equal to the angle of elevation. Okay, so just keep that in mind if you're doing that question. So angle of depression does go with angle of elevation. Depends where you're looking from. Okay, so here you are right here, you're looking up, you're looking to elevation. Here you are, you're looking down. That's the angle of depression. Okay, hopefully that helps clarify that because I know I've seen that in the past a little bit. All right, moving right along. This is going well. Let's take a look at grade. All right, so grade, all right, basically it says right here, grade is essentially expressed as a percentage. The steeper the slope is, the higher the percentage. So grade is slope represented as a percent. Okay, so that's why we get percent grade going on there. Percent grade, right? Like this is 8%. So the way that would look is that would be 8. So our rise would be 8 over 100. Okay, so that would give us 8%. So again, understanding fractions and percents and decimals really important to this unit and making sure that you understand it all there. Okay, so again, Josette wants to build a skateboard ramp with 20% grade so that the top of the ramp is level with the rail at 30 centimeters high. So we have 20% grade, 30 meters high. How long does the ramp? So when I look at high, again, I'm thinking here, that's got to be my rise, right? That's my vertical. And then how long? When I look at the word long, that should help me figure out, well, that's my run. All right, so like we just said before, 20% grade. So that means that my slope would be 20 over 100. Okay, so again, the way I got that, you looked here, you can see I went from 8 over 100, that's 8%. If it gives me 20%, I can do that. Now, if you want to, you could leave it like this, but let's go back to the lowest terms. I know that I can divide 20 into both of these, and that's going to give me 1 over 5. So I just have smaller numbers to work with right off the bat. If you use 20 over 100, it's still going to work. Okay, so that's my slope. I also know that my rise is 30 centimeters high. So what I need to do now is to go slope, which is 1 over 5, equals my rise, which is 30 centimeters, over my run, which I do not know. And that's what I need to look for. Okay, again, you can see here that we're going to cross multiply. And this 1 times x is x. 5 times 30 is 150 centimeters. So boom, there it is. That's what our how long of our ramp would need to be. Okay, so we don't even have to round answer to the nearest centimeter. Well, we're already there. Cool. All right, hopefully you guys are still with me. Pitch. Again, pitch is would be, you can talk about, it's just another way to explore what steepness is or slope. Okay, it's just another way that is sometimes used to explain it. Pitch is the same thing. So when you look at this diagram too, how wide is the diagram? If the pitch, so the pitch would just be your slope. So again, in this case, m would be 3 over 4. All right, and that's the pitch on one side, and that's the left side. So this would be left side, this would be right side. Oops. And yeah, you need to use those information. The right side has 8 over 9, so my slope on my right side would be 8 over 9. So you could use this information totally, because here you can see here you'd have a little bit of run, right? Once you figure out, if you use your slope and your run, you can find your rise. And once you have your rise here, you can see these triangles share the common rise, right? The common side. So once you find your rise here, what then you would be able to do is to find using this slope here, you'd be able to find your run here. And then you would add these two up together to give you your width of the shed. All right. So hopefully that helped you out and made some sense. And if you have any questions, again, please message me on Remind, email me, write some comments in your OneNote, come see me in person, Flipgrid. Hey, just get a hold of me and let's help you out. All right. Thanks a lot. And thanks for watching and listening. And thank you.